Let's do section 10.2, page 496, exercise 10, which reads, use the table of Maclaurin series to construct the first three non-zero terms and the general term of the Maclaurin series generated by the function and give the interval of convergence. So for number 10, our function is f of x is equal to x squared times cosine x. Now remember that you have this wonderful table that has a whole bunch of common functions, and that you can take all those functions and you can add them together or subtract them. You can multiply through by things. So it might be a good first step to look at what the Maclaurin series is for cosine x. And so I've written that down here. And cosine x is equal to 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial plus dot dot dot, the general term, which is negative 1 to the n, times x to the 2n divided by 2n factorial, and then the series just continues. So we could probably just take this Maclaurin series and multiply it by x squared. So I'm going to give myself a little room here, and I'm going to have x squared times cosine x, and I'm just going to multiply each term in my series by x squared. So I'm going to get x squared minus x to the fourth over 2 factorial plus x to the sixth over 4 factorial. And then, of course, I'm going to have my general term. And multiplying by x squared doesn't really change my negative 1 to the n. It is, however, going to change my x to the 2n. And that's because every time I'm going to add an extra x squared. So my new exponent is going to be 2n plus 2. And again, this doesn't really change what's in my denominator, so that's still going to be 2n factorial. And I can still extend this out to infinity. So I have my first three non-zero terms, I have my general term, and the interval of convergence is going to be all x, just as it was for cosine x, because multiplying by x squared hasn't really changed anything that would affect what my interval of convergence is.